So before we start, any question? Any question for so far? Okay. So far online, okay. Any foreigner here? Okay, guys, can you see the slide that I share? So for the teaching plan. All right, so now we have 24 participants. So maybe we wait another 1 minute and then we will start our class. Okay. So actually today is no lecture lah. Today is no lecture, just a briefing on the technical, on the teaching plans. Okay. The syllabus for will be covered for these subjects. Okay. So actually this subject is the principle of instrumentation and measurement lah. BEKG 1, 2, 3. Okay. So I will wait another 1 minute and then we will start lah. So maybe just half an hour, okay, very quick. So our lecture will be start on the next week. Okay, clear? Eh?
Clear, sir, clear.
All right. Okay, so now 35. So based on the attendance, I think around 28 lah, 28. So any foreigner here? Ada foreigner ke? If not, I can use the mix, okay, mixed language. If you have a foreigner, so I will use the English lah. Any foreigner? Okay, so let's start. Boleh start Okay.
Boleh sir, boleh sir.
Boleh.
So, okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. So today is the first online class for this subject, BEKG 1233. There is a principle of instrumentation and measurement. Okay, so that I mentioned to you before this, today is no lecture because for this section we will have the team teaching. Okay, me and another one is the PM Dr. Rahim. So just only yesterday we got the notice for the team teaching. So that's why, so the class will be start on the next week. So today just a briefing on the teaching plan. Okay, the syllabus and the assessment for this subject lah. All right. So let me introduce myself first. All right. So my name is Dr. Muhammad Syahril bin Muhammad Aras from Faculty of Electrical Engineering. You can call me Dr. Syahril. So for this subject, actually that I mentioned to you is the team teaching. Okay. So me and PM Dr. Rahim. So I will cover for the 3 chapter, and then Dr. Rahim will be cover for another 3 chapter. All right. So and then we will be switched lah. Okay. So for the first 3 chapter will be covered by me. That I mentioned on the group. Okay, WhatsApp groups. All right. So this is the BEKG 4233, principle of instrumentation and measurement. If you see the title, okay. Yeah. So we have another participant. All right. Okay, if you see this one, principle, that means principle is the more on the fundamental. Okay, more on the fundamentals, on the theoretical of the instrumentation and measurement. That's the device that we use to measure some quantity lah. Okay, for example, to measure the electrical quantity, for example, measure the voltage, measure the current. So how to measure the current, how to measure the, actually we cover on the device itself, the component itself. That means, for example, like multimeter, okay, oscilloscopes, okay, DC meter, AC meter. All right. So the first learning outcome for this subject, actually, at the end of this semester, you should be able to describe the principles. That means the theory, all right, the fundamentals, the various term and the standard in measurement. Okay, we have the standards, okay, system international standard. So for example, like length, okay, the time. So we have the international standard. Okay, we have to know lah. And then second learning outcome will be explain the principle of measurement device. All right, the basic of the device lah. For example, like multimeter, oscilloscope, how the oscilloscope works. Okay, the component inside the oscilloscope, that will be covered on this topic lah actually. So actually this topic is more on electrical, electronic, and some part of the mechanical. Okay, mechanical lah. So that's why you have to know at least the basic one lah. For example, like we have another participant. All right. Okay. Like the oscilloscope, AC meter, DC meter. So at least you know some basic instrumentation or measurement that you want to use when you're working outside. All right. So third learning outcome will be apply the suitable bridge technique, okay, to measure component value such as resistance, inductance, and capacitance. So actually we have 2 types of the bridge. Okay, we have the AC bridge, DC bridge. Okay, we'll be covered on this topic. And then linear outcome number 4 will be explain the operation, functions, and application of the transducer or the sensor. Right, clear? Okay, guys, clear? Can proceed?
Yes, yes, sir.
Clear, sir.
Oh,
Clear,
if you have
Doctor.
any question, you can ask. Don't worry. So today is no lecture. Today is no lecture. Just briefing on the technical teaching plans. Okay. All right. So this is reference for this topic. You can refer to this one. Okay. So we go for the subject evolution. All right. So as mentioned here, we have the quizzes. Okay, 5%. Normally for online, I'm not sure. So before this, I don't do the quiz. I just based on the attendance. So if you come to normally face to face lah. If you come to my class, automatically you get 5 marks bonus lah. For online, I'm not sure. So maybe we just do a simple quizzes lah, so that you can score the 5 marks. Okay, 5 marks for the quizzes. All right, and then the midterm test, we have 20%. Midterm test, 20%. And then the assignment lah. The assignment will be 50%. I think this is standard, I think. The standard assessment lah for every subject. And then our final exam will be 60%. Okay. Clear, this one? Okay, guys, clear for the subject evolution. So we have
Yes, sir.
Clear,
Yes,
sir.
yes.
one test, we call the midterm test. Assignment will be maybe on the group assignment. Okay, we do that just because of the MCO. So maybe we can do the online assignment and then also the quizzes. Okay, and then final exam will be 60%. All right. So this is for subject assessment subject evaluation. Okay. Next we go for the syllabus, the content for this subject Okay. You can see the slide here. All right, so for the chapter 1, actually chapter 1 is the introduction to the instruments and the measurements. All right. Okay, so on the chapter 1 will be introduction. Okay, so on the chapter 1 also we have to use the SI unit. SI is the system international units, the dimension, standard of measurement. Okay, the standard of electrical measurements. Okay, when we do the sum measurement, maybe we have the sum error. Okay, you have to know what is the type of error. Okay, and then after you do some measurement, a lot of measurement, you have to do some analysis that we call the statistical analysis. So based on this analysis, you can calculate the accuracy, calculate the precision of the measurement. That will be covered on the topic number 1, chapter number 1. Also the topic number 1, okay. So the error how to reduce the error. Okay, how to reduce the error. Maybe one of the technique is to calibrate the device. Okay, calibrate the device so to reduce the error Maybe we can call the offset error. Okay, what is the offset error? Will be covered on these topics. That's why we have to calibrate every device. For example, if you do some measurement, first thing we have to calibrate our device. Okay, after calibrate, then we do some measurement all right, and then also cover for the topic number 1 will be noise. Okay, so for example, like you can see, if we measure the DC motor, DC supply. For example, DC 12 volts. Okay, 12 volt supply. So if we use the multimeter, it's suppose theoretical we get the 12, okay, 12 volts, but maybe some of the noise. Okay, that's why you have to know what's the type of noise. Okay, so maybe the reading cannot get the maybe plus minus. Okay, 12 point something or less than 12 lah. Okay, that's the side effects. Okay, of noise effect lah. And then last is the noise reduction lah. So we have to know how to reduce our noise lah. Okay, that will be covered on the topic number 1. Okay, topic number 1 normally is the theoretical lah. Okay, and then chapter 2 will be DC meter. Okay, so we have to know how the DC meter construction and the function of the DC meter. So on the DC meter, we have the three type of DC meter, such as a DC ammeter, voltmeter, and ohmmeter. Okay. And then also on the chapter 2, we cover on the voltmeter loading effects and ammeter insertion effects lah. So this will be covered on the topic number 2. Okay. So and then chapter 3 will be AC lah, AC meter. So the AC meter, we have study about the half meter rectifier voltmeter, full wave rectifier voltmeter, and other type of AC movement meter, and then dynamometer movement, iron van meter movement. Okay, that will be covered on the chapter 3 lah, on the AC meter. Okay, so the topic number 1, chapter 2, and chapter 3 will be covered by me. Okay, and the rest, okay, chapter 4 until chapter 6 will be covered by PM Dr. Rahim. All right, so for the chapter 4 will be oscilloscope. Okay, this is oscilloscope. You have to know the basic construction of the oscilloscope. Okay, the basic operation of oscilloscope, how to use the oscilloscope. Okay, how to use the voltage measurement will be covered on the topic number 4 lah. Okay, so this is the topic number 4. Okay, then also we have the frequency phase measurement using the oscilloscopes. Okay, Lisa choice figure and application, overview of digital storage oscilloscope. So now, so you can see this one, actually we have the cathode ray tube lah. This is the all version of oscilloscope. So now I think on your lab, I'm not sure on your lab. So on the FKE lab, so normally we go for the digital oscilloscope, a very small oscilloscope. Not before this, we have like the all vision TV lah. For the all vision TV, they use the cathode ray tube and so very big size. Now they use the digital, so very small lah. Okay, oscilloscope. Then chapter 5 will be DC bridge. Okay, so also DC bridge. This chapter 5 will DC bridge. We have to study about the DC bridge. Okay, basic circuit of the Wheatstone bridge. Okay, Wheatstone bridge sensitivity and so on lah. So this is for chapter 5, and chapter 6 will be AC bridge. Okay, I mentioned to you, chapter 4, chapter 5, and chapter 6 will be teach by PM Dr. Rahim. And last, chapter 7 will be your assignment lah. Actually, chapter 5 will be on the sensor. Okay, or sometimes we call the transducer. Okay, sensor or transducer will be same lah. So on the chapter 7, normally we don't cover on the class. We just do the some assignment. Okay, maybe the group assignment will be select one sensor. Okay, you have to discuss the construction, the function of, for example, like the pressure sensor, thermocouple, okay, thermistor, and so on. Right, that is the for chapter 7. Normally chapter 7 no class lah, no lecture, but only the assignment lah, the maybe the group assignment. Okay, so just choose only one sensor, and then from this sensor you have to explain the construction of this sensor, how it works. Okay, and how this application for using this sensor lah. Okay, that is the syllabus for this subject lah. So normally we have chapter 1 until chapter 6 will be covered on the lecture, and then chapter 7 will be covered on the assignment. Okay, will be covered on the assignment. All right, so far any question for syllabus? Boleh? Boleh guys? Okay.
Boleh.
All right. So if you have any question, you can ask, don't worry. Okay, this is for okay, detailed syllabus. Okay, detailed syllabus for this subject. Okay, that's all. Okay, that's all for today. So any question? I mentioned to you before this. Suppose the first, actually the first 3 chapter normally first yesterday lah we discussed with Dr. Rahim. Suppose he mentioned to want to teach chapter 1 until chapter 3. Okay, that's why after a few discussions, so because they're very busy, all right, so that's why just switch me. Okay, we will cover on chapter 1, chapter 2, and chapter 3 lah. That's why our class will be our lecture will be start on the next week lah. Okay, the technique maybe okay. The technique for the class maybe I use the online similar like this one. Okay, maybe using the Webex. So I'm not sure why today I tried to using the Webex. So not sure some error on the camera and my microphones. So that's why I changed to Zoom. Okay. So another technique, maybe I use the video, okay, video presentations and upload to my YouTube. So and also you can refer to my YouTube. Okay. Don't forget to subscribe. Okay. Don't forget to subscribe. Okay, like and share on my channel. All right. So maybe I will upload my video presentation because I'm not sure. So maybe we don't sure. So maybe if I have time, so maybe I just do some video presentation or some analysis using the video presentation lah. Okay. So far okay. Any question?
Sir,
Oh,
untuk midterm sampai chapter berapa, sir?
Alright. So the midterm normally we just cover on chapter 1 until chapter 3. But I will confirm again. Okay. Normally chapter 1, chapter 2 and chapter 3 will be covered on the midterm lah. Okay, midterm test. Okay, clear But I will confirm again lah. So because I'm this subject, Dr. Hairul Nizam will be coordinator. Okay, Dr. Hairul Nizam will be teacher for the section 1 and section 2. Okay, and then section 3, me and Dr. Rahim. All right, so the coordinator for this subject will be Dr. Hairul Muhammad Nizam. So it will be set lah the question for midterm based on the previous. Normally the chapter 1, chapter 2 and chapter 3 will be covered for the midterm test lah. Okay, the rest will be covered on the final lah. Normally like that, but I will confirm you again. Okay. So any question so far? Line okay? Clear tak? Jelas tak? If you do online,
yes, sir.
boleh eh? Alright.
Jelas
Ini
doktor.
okey, doktor.
Okay, clear eh?
Ya.
Alright. Okay, so this is all version. Okay, this is I think that's all for teaching plan. Okay, teaching plan. All right. If you have any question, so you can ask. Okay. If not, so maybe we stop here. All right. So we will start on the next week. Next week we try. Normally my class will be 2-hour class online. So if you, for example, maybe next week we try. If you are finished on the Monday, so on the Tuesday we don't have the class. Okay. Clear Boleh Can?
Boleh, sir, boleh.
Try to finish on 2
Boleh,
hours.
sir.
only.
Boleh doktor.
Okay. Kalau in case we have to more time, so we cover on the Thursday class lah. Alright. So we try to do only one class per week lah. But we'll be full swing for 2 hours. Okay, for 2 hours lecture lah. That means we only have one class per week lah. Okay. So maybe if on the near to the midterm, so maybe we do some tutorials, okay, or some exercise on the cover for cover will be cover on this subject lah. Okay guys, boleh?
Boleh. Boleh.
Boleh, doktor.
Kalau Zoom, I'm not sure, but before this I used the Webex. We can see all the participants, but on the Zoom I don't see you. So how to set Siapa tahu? Saya nak set. How to set to see all the participants? I just okay. Right now we have 31 participants. 31 participants. Okay, this one is your attendance lah. Based on this one, this is your attendance. Okay, based on the participant, I just take as the your attendance lah. Okay, so far okay.
Okay, sir. Okay, sir.
All right. So if you have
Okay,
no
sir.
questions, so I will stop here. So we will continue on the next week. So we will see you on the next week's Monday. Boleh eh?
Boleh.
Boleh,
Sir.
sir.
Alright. Okay.
Boleh, sir.
See you.
Semangat tu.
Semangat ke?
Sabar.
Sabar. Let lu. Oh.
Okay. Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. Alright. So today is the first lecture for our class. It's the principle of instrumentation and measurement, BEKG 1233. Okay, the first topic will be on the introduction of the instrumentation and measurement. So that mentioned the previous the last week's class. Actually, the principles means fundamentals or sometimes relate to theory. Okay, relate to background on the instrumentation and measurement. That means on the device. Okay, on the device that we use to measure the quantity lah. Okay, the quantity. That is today class. We just focus on the introduction of the instrumentation and measurement. All right. So first of all, this is learning outcome for chapter 1. All right. The first learning outcome will be able to be define various measurement, okay, and instrument principles, applications, okay, terms, and then the standards. All right. So this is we cover today lah. Okay. And then so learning outcome number 2 will be able to define and explain the following type of error that occur in the measurement. Okay, such as gross error, okay, systematic error, okay, random error. Okay, before that, so this will be covered on the next class lah. All right, before that, I will have a new announcement. The first, so tomorrow also we have the class. All right, so tomorrow we have the class also at the same time, 11 to 1, okay, to cover with this topic lah. Because the next week we don't have the class because I have another workshop to be attend. Okay, so I'm an editor for the for the agritasi for FTKEE. So so next week on the 26 and 27. That's why the next week we don't have the class, but I will try to upload the video for the next week. Will be on the will be covered on the noise lah. So tomorrow class will be covered on the error, okay, error and the specific method, and then the next week we cover on the noise. Okay, this is for chapter number 1 lah. So another announcement. So this that I mentioned to you the previous class. Suppose this subject will be team teaching. I'm and Dr. Rahim. All right. So unfortunately, Dr. Rahim cannot join us. So I will teach you all this. Okay, all of the semester lah. Okay, for this subject. All right. Okay, that is the new announcement for this subject lah. Okay, clear class? So next week no class Next week no class. So I just upload my video on the noise, so you can watch my video on the YouTube lah for the next class next week class. Okay, tomorrow we have the class. Okay, same 11 to 1, right? So the learning outcome number 3 will be able to use the basic statistical method for analyzing measurement error, accuracy, precision, and limiting error lah. So this one will be covered on tomorrow class. Okay, so you have to know what is the type of error. Okay, for example, we have the gross error, human error, systematic error. On the systematic, we have a lot of error inside the systematic, for example, like instruments, okay, error and so on, and then also the random error lah. So and then after we got the error, so we have to study on the statistical method lah, to study the error, okay, the type of error, and then study of the accuracy, precision, and then how to limit the error lah. Okay, and then last but not least, for the learning outcome for chapter 1, we'll be able to describe the type of noise occurred in the measurement, okay, the effects and the reduction technique lah. So this is the learning outcome for chapter 1. All right. So next we go for the introduction. Okay, that's why that mentioned to you, this class actually more than 60% is the theoretical lah. Okay, more than 60% theoretical, and then 40% is the maybe on the calculation. All right. All right. So okay, the introduction is the first is the instrument lah. So what is the instrument? Instrument is the device or mechanism, or sometimes we call equipment, to use to determine the value or magnitude of the quantity under observation lah. So okay, sometimes we can call as the equipment lah. Equipment that we use to measure the magnitude or the quantity. For example, like okay, so so this is we call the digital multimeter. Can you see this one, digital multimeter? All right, so this one to measure the voltage, okay, to measure the current lah. For example, this is one of the instrument, electrical instrument, to measure the voltage and measure the current lah. All right, so actually we have another, for example, like this one, okay. This one also we call the instrument lah. Okay, this one is the instrument. This one to make, we call the anemometer. Anemometer is to measure the wind speeds, and also we can also measure the temperature lah. All right. Okay, so another one. Okay, also this one lah. Okay, this is manual lah. This is manual. This is to measure the length lah. To measure the length, but we use the manual. Okay, for example, okay, this one. Okay, this one is the clamp. Okay, it's the clamp meter. Okay, to measure the current lah, to measure the current. So for example, we have the cable here. Okay. Okay, for example, like this one. Okay, we have the cable. So we have clamp here. So and then we can display here lah. All right. So this one we call the clamp cable lah, clamp meter. So to measure the current lah. So this is some example, the device that we use to measure the quantity or measure the magnitude. Okay. Right, so for the electronic instrument, so electronic is the based on the electrical or electronic principle for its measurement and function lah. For example, like okay, electronic musical instrument lah, like apa, electrical guitar, alright, like electrical piano, okay, keyboards, okay. So that's we call the electronic instrument lah. Okay, that means based on electrical or electronic principle for its measurement function lah. Alright. So it's a musical instrument that generates sound electronically. Similar like electrical guitar, okay, piano, keyboards. Okay. So next is the instrumentation system. Okay, instrumentation system is the physical system, which is a collection of physical objects connected in such a way to give the desired output response. Okay, for example, like this one. Okay, for example, we have our system here. This one we call our system. Okay, and then on our system we have the outputs, and also we have the input here. Okay, and also we have the feedback. This one we call the instrumentation system. Okay, this one is the feedback lah. Right. So this one we can also call the instrumentation lah. For example, like we have the hydraulic system, okay, electrical system, thermal system, and also other non-electrical system quantity lah. All right. So next, the introduction is the instrument may serve three basic functions. Okay. For the instrument, we have three basic functions. The first is the indicating. Okay, indicating is the indication of the value parameter under observation. For example, like this one, we have the digital. Okay, we have the digital multimeter. All right, so when we use this this probe to measure the voltage and measure the current lah, for example for this digital multimeter. Also another example like oscilloscope lah. Oscilloscope, we can use the oscilloscope to measure the voltage, to measure the current, for example. All right, so this one we can display the output, the output for the battery, for the measure the voltage, the output for the voltage or current, and so on. And then second basic function is the recording. Record, to provide the permanent graphic record of the variation in the value of parameter under observation with respect to the time. So another example is the strip chart recorder. Also oscilloscope, also you can also record the parameter lah. The value of the parameter. For example, like digital multimeter here, you cannot. This one, for example, this is not, cannot recording, just indicating. Just indicating. This one not recording or controlling. This for indicating. That's when can measure, but cannot record and cannot control. Just only the measure. Do the measurement lah. All right, and then another function for the instrument is the controlling. So to provide the control of the system or the internet, such as for example like an automatic control system. So that I draw before this. So this is for our system. I mentioned to you. So this one we can control. So this is input and then this is the output. This is feedback. So actually inside the system we have the control, we have the controller and we have our system our plant inside this system That's why this part we can control the plant, the system. That's why some of the example is the automatic control system this is the 3 basic function, but not all the instrument have the 3 basic function. Only one is okay. For example, like I mentioned to you, like this one. This is simple instrument. This we call the anemometer that I mentioned to you. We can measure the wind speed. Wind speed, or we can measure the temperature. Here I on first. Right, so you can see this is on. So when you we can measure the wind speed. This is an example of the instrumentation basic function. But this one only one basic function. This is the indicating. That means measure the wind speed or measure the temperature. So maybe some of the instrument can do the measurement and also do the recording. For example, like oscilloscope. Our digital oscilloscope, we can do the measurement. And also we can do the recording. Record the output the value under respect with the time. Right, so this is a basic this is 3 basic function for the instrument. First is the indicating, recording and control. Next, measurement. So measurement is the process of determining the amount, the degree or capacity by comparing with the expected standard of the system being system unit being used All right. So measurement, we measure the quantity. We measure the quantity. That means the process of determining the amount of or value you want to measure For example, like digital multimeter, we want to measure the voltage or we want to measure the current. So we have to do some measurement That's we call the measurement. All right, and then the physical embodiments of the unit of the measurement, as well as there is its multiples or multiples value. That's called the standard That's on the standard. We have the 4 type of the standard. For example, like we have the SI standard. This means the international standard system, international standard. We have the primary standard, we have the secondary standard, we have the working standard, and so on. I will explain after this. And then the device used for comparing the unknown quantity with the unit of measurement or the standard quantity is called the measurement instrument. Okay, measuring instrument. Okay, for example, like our anemometer. Okay, so digital meter, our clam meter, and so on. Okay, so on the measurement, actually we have two type of the measurement. First is the direct, okay, direct measurement. Okay, for example, like we have the here, so we have the digital multimeter here, and then actually we have the battery here, right? This is the battery. So you can see on the battery, okay, see this one, eh? So we have 14.8, okay, 14.8 volts, okay, 14.8 volts here. This is a standard, okay. Okay, we use the digital multimeter here. All right. So and then we measure the voltage. Okay. All right. So you can see this one, 15.07. 15.07. Okay. All right. So this is we call a direct measurement, direct measurement. So for example, this one is the indirect. Another method is the indirect measurement. So indirect measurement, that means the unknown quantity is determined by measuring other function, functionally related to quantity, and calculating the desired quantity rather than measuring it directly with the instrument. Okay, for example, to measure the resistor. Okay, resistor. Okay, yeah. This is ohm law lah. Okay, for example, like actually is the Ohm's law, V equal to I R. Okay, this is Ohm law, Ohm's law, Okay, for example, like okay, this digital multimeter, okay, this digital multimeter actually, this digital multimeter also can calculate the resistor also, That's why you can see the value here is the ohm, so automatically we can measure the resistor. For example, this digital multimeter cannot calculate the resistor, so only calculate the voltage and current, okay, but we can use the formula lah, V equal to IR, that means R equal to V over I, okay, voltage over current lah. So first we measure the voltage, and then we measure the current. So we divide by voltage by current, so we got the resistor value lah. So this one we call the indirect, okay, indirect measurement. For example, another example like, okay, so we have another example formula here. P power equals to I V, okay, or voltage multiplied by current. All right. So this is okay. So this is you can see this formula for power. So we cannot using this digital multimeter. We cannot use cannot calculate measure the power, but we can measure the voltage and we can measure the current. So automatically from this one we can get the power value. That means this one we call the indirect measurement. Okay, we measure the other quantity, then from other quantity we use the formula to get the value. Okay, the value of power, for example. So this one we call the indirect measurement. Okay, clear, class?
Clear, sir, clear.
Okay, this one we call it indirect lah. Indirect measurement. So next is the direct measurement lah. Okay, direct measurement. Let me show to you. So we can directly use the multimeter. Okay, on the all right. On the direct measurement, we have two techniques lah. First is the deflection methods. Okay, deflection method actually is the normally before this we use the analog, analog. So this is the digital multimeter. Automatically, okay, all right. So automatically we got the value here lah. Okay, 0 point something something. But in analog we have to see the scale. Okay, the scale. For example, okay, we can see the scale movement lah, the pointer movement. All right. So that is the analog lah. Okay. So the deflection method is the value of unknown quantity is determined by means of the measuring instrument having the scale graduated to the quantity under measurement directly lah, such as a measurement on the current with the ammeter. Okay, ammeter. So actually using the digital multimeter, we can measure the current actually, but this is digital, so we cannot use the analog lah, the pointer. Okay, if you use the analog, you can see the movement of the pointer lah. For example, like okay, for example, like our watch. Okay, watch is this one is the analog. Okay, so you can see this is deflection method lah. So will be in place that we can measure this watch. You can measure the one of the instrument lah, but not electrical instrument. We can measure the times. Okay, for example, using the watch. Also, watch we can use as the instrument lah, because watch can measure the time. Okay, so if you have the analog, okay, analog watch, so you can see the pointer will be increased lah, right, gradually. Yeah, so that's we call the deflection methods. Okay, so another method we can call the comparison method lah, that I mentioned to you, that I show to you. So this battery, for example, okay, this battery we have here the spec will be battery here will be 14.8 volts. Okay, 14.8 volts. All right, here. Okay, when we do the some measurement, okay, using the digital multimeter here, okay, measure the voltage here. Let me show you. All right, so the measurement will be 15.07 volts. Okay, that's one we call the comparison method lah. All right, we measure and then compare with the standard. Okay, the standard cell will be on 14.8 volts, but the measurement will be 15.07 volts. So this one we have the error. Okay, we have the error lah. So this one we have the error. So tomorrow we'll be studying on the error. Okay, what we call this error, right? Okay, so on the comparison method, we also have the include the null method lah. Null method will be explained after this. Okay, null method measurement, measuring current or voltage more accurately by balancing the circuit so that no current flow through the measurement device lah. Okay, this one will be covered on the AC bridge or DC bridge lah. Okay, this is the all method. Okay, all method. Okay, all method to measure, to do some measurement lah. Okay, we have to do some balance the circuit, and then so that no current flow, then we can use we can measure the output of the voltage. Okay, so this one will be covered on the AC, DC bridge and AC bridge lah. Alright, so on the AC and DC we have the, for example, we have the Wheatstone bridge and so on. Okay, this one we call the null measurement method lah. So null measurement method is more accurate. Okay, more accurate, but very complex. Okay, we have to develop the circuit. Okay, and then after develop the circuit, so we can measure the volts. Okay, measure the voltage or measure the current lah. Very complicated system lah to do this measurement. So if we have the digital multimeter, so direct, okay, direct forward lah, we can use the direct measurement. Okay, direct measurement lah. So this one is the one of the direct, also direct, but very complicated lah. But the output will be accurate, more accurate compared than this one, compared than digital lah. That's why you can see. So for example, like BT, our cell will be 14.8 volts, but when we measure the digital multimeter, we got 15.7, okay, 15.7 volts, okay. Okay, guys. So I will send you can refer to the chat. Okay, I send the Google form, so you can fill out this Google form lah. Write your names and your matric number on the chat. Okay, you can refer to the chat room. All right, so I already give the the link on the Google form. So you have to write your name and your matric number. Okay. All right. So next we go for the SI unit. Okay, SI unit is the System International Unit lah. Okay, this is the nature of unit lah. So engineering quantities of the different kind are involved, including the physical, chemical, mechanical, thermal, electrical, physiological, and so on. Okay, and then in order to record or to compare magnitude of the quantities, some one magnitude of each kind must be taken as the basic or unit lah. So each unit either must be represented by the physical standard or some kind, nature or artificial, or must be derived from the combination of other unit represented by such standard lah. Okay, I mentioned to you we have the international standard. Okay, we have the international standards. That's why we have to follow lah. Okay, this one is the fundamental quantity of the SI system. Okay, SI system stand for System International. Okay, in French. Okay, this abbreviation is now adopted by the International Standardizing Organization as the abbreviated name of this new system of unit in the all language lah. So that means all the country will be use the standard. Okay, the international standard lah. Okay, this is a SI system is the comprehensive, logical, and coherent system lah. Okay, designed for use in the all branch, okay, of science, engineering, and technology. Okay, you can see this one system international SI system consists of 28 units. Okay, we have the 7 base unit. Okay, 2 addition unit and 19 derived unit lah. Okay, so we go for the what is the base unit. Okay, this is the base unit. Okay, we have the length, okay, the mass, the time, temperature, luminance intensity, electrical current, and amount of sustains. Okay, so this one we call the base quantity. Base. Okay, is the base unit. So this is symbol for length. Okay, length. Okay, symbol for mass. Okay, mass. Okay, time, and so on. Okay, from this base we can derive lah. For example, like okay, velocity. How to calculate the velocity? So velocity is a length of divided by time. So we got the velocity. That means we derive from this basic, okay, the base unit. All right. From this base unit, we can derive another unit. For example, accelerations. All right, and so on. Okay. So the dimension. Okay, the dimension is the derived unit is recognized by the dimension and can be defined as the complete algebraic formula for the derived unit lah. Okay. Okay, the dimension equation help to conversion from the one system of unit to other one lah. And then derivation of the equation for the physical quantity and checking the accuracy of an equation lah. Okay. For example, okay, here, so some derived unit have been given new name. Okay, for example, like we know. So from base, okay, from base unit, length divide by time. So actually we got the velocity. So velocity is the new name lah, velocity or acceleration. So acceleration, that means velocity divide by time. So we got the acceleration. So acceleration is the new name. Okay, we can give a new name for this, but this is okay. For example, like okay, Newton. Okay, here Newton. So instead, dimension if correct name is the kilogram meter per times apa s squared. Okay, s power of 2. Right. So this is some example lah. Dimension to you. Some of the example. Find the dimension of the derived unit. Okay. For example, like first is the velocity here. Velocity here. So from this velocity, from length divided by time, so we got the velocity. So velocity is the new derived from the base unit lah. Okay, and then acceleration, okay, velocity divided by time, we got the acceleration, right? And then force equals to mass multiplied by acceleration, okay? Works, okay, force multiplied by length and so on. Okay, this one is the derived from the basic, okay, from the basic unit lah. Okay, so this is another example. All right, we can use the the formula here. This is symbol for length. Okay, okay, we can also actually length we can standardize using, for example, depends on the length lah. For example, we can use the kilometer, we can use the meter, we can use the cm, depends on the measurement lah, depends on the measurement. If too long, so we have to use the kilometer lah, kilometer. If very short, so maybe you can use the, for example, the cm, only the centimeter. Okay, depends on the apa, the quantity you want to measure. All right. Okay, so you cannot write your name. I will check. Yeah. Okay, I will check first. Okay, for example, your name. Okay, and then the matric number. Oh, you put, okay, must be greater than 1. Okay. Maybe I set the wrong format here. So don't worry. So it's okay. No need to fill up this. Maybe I just wrong set for this one. So okay, it's okay. Okay. I will share after this lah. I will share after this. Okay, sorry for but this okay, this maybe I set the wrong formula for the because I just edit from the previous Google form. Okay, right. So maybe some mistake on the. I will pass after this on the WhatsApp group lah. Okay, so let's continue lah. Continue on our lecture for today. All right. So that's mentioned to you. We have the standard. Okay, this is we call the standard of measurement. All right. So the standard of measurement is a physical representation of the unit of measurement. So unit is realized by reference to the arbitrary material or to the natural phenomena, including physical or atomic constant. So a standard is known as the accurate measure of the physical quantity. Okay, standard are used to determine the value or other physical quantity by comparing method lah. Okay, for example, like I mentioned to you, first this is like our battery is the standard. Okay, we have the standard value 14.8 volts. Okay, so and then we can use the another instrument to measure this this battery that we call the comparison method lah. Okay, and then we have on the standard we have 4 categories standard. There is the international standards. Okay, the mentioned to you is the SI system. There is the international standard. And then we have the primary standard, and then we have the secondary standard and working standard lah. Okay, so we go one by one. What is the international standard lah? So international standard is the international agreement, and They are represent certain unit of the measurement to the closest possible accuracy that production and measurement technology allows. All right. So these standards are maintained at the International Bureau of the Weights and the Measure in the Paris lah. Okay. So we have the international standard lah. This one is the international standard lah. All right. Next is the primary standards. Okay. Actually, this primary standard is depends on the country. Okay. On the country lah. So every country they have their standard lah. For example, like Malaysia, we have the SIRIN. That's why you can see on the electricals, okay, on the electrical device, okay, electrical instrument, we have certified by SIRIN. Okay, we have that's for example like our television or our electronic device, we have the SIRIN chop, okay, chop SIRIN. That means this device already approved by SIRIN, already tested by SIRIN. Okay, the SIRIN will be is the primary standard lah. On Malaysia, we have the National Standard Laboratories in SIRIN. So we be give the certified or certificate for the all the device, okay, all the for example like instruments, okay, electronic instrument and so on. Okay. That's why you can see on the electrical part. So they have the MS, that means MS2 Malaysia standards, okay, and then another one will be approved by SIRIN. So that is on the Malaysia part lah. Okay, that's we call the primary standards. All right, the secondary standard. Okay, this standard are basic reference standard used by measurement and calibration laboratory in the industry lah. All right, so some industry they use the some part of the measurement and calibration. Yeah? So this one is the secondary. Some example like us, we do some experiment in our lab. So this is called the secondary standard lah. Okay. On the, for example, like our oscilloscope, we use the digital multimeter or we use the emitter and so on. Okay, do some measurement and calibration in our lab. So this one we call the secondary standard lah. Okay. And then another one is the working standard lah. So the principle of tool of the measurement laboratory lah. So they are used to check and calibrate the instrument used in the laboratory. Okay. To make comparison measurement in industrial application lah. Okay, and that for example like for us we have to test, okay, we have to test the device, is it okay or not, and then we have to calibrate. Then also this we can use on the industry. Okay, actually our part will be similar like industry lah. So the industry use this standard, okay, we use the working standard. So for our, we use the secondary standard lah. That means we have to double check on the industry standard lah. Okay, for example, like manufacturer of the electronic components such as a capacitor, okay, resistor, many more use the standard called the working standard lah for checking the component value being manufactured. Okay, there is some example lah. So this is a summary, summary of the standard. Okay. So you can see the international is the high standard lah, very high standard. Okay, we have to follow the high, okay, the international standards, and then the primary, okay, the primary standard is the accuracy lah. So this one also certified by, for example, like Malaysia is the SIRIN lah, okay, the SIRIN. But this one no need to certify secondary standard and working standard. This one used for our in our lab. But if you want to do the measurement, okay, to do a certified, so you have to go for the primary standard lah. That means your device, for example, I designed this digital multimeter. So I designed, okay, the new one for digital multimeter. So first I just use for the working standard and secondary standard. But I want to sell this digital multimeter. So how to see this is good or not? So you have to apply the primary standard lah. Apply the primary standard. That means I go for the SIRIN, and then the SIRIN will be do some experiment and some testing on this digital multimeter. Then after that, if it's good, okay, it's okay, and then will be fulfill the characteristic of the primary standard, then will be certified by SIRIN lah. For example, that's why our electronic device, that's why when we buy you want to buy the electronic electronic device, okay, the component, for example, we have to check, is it approved by SIRIM or not, okay? That means if approved by SIRIM, so that means your device already tested in the SIRIM lah, already certified, okay, already tested, do experimentals, okay, measurement in the SIRIM, okay. That we follow the primary standard lah. Our device will be follow the primary standard. That's why the first step, if you want to buy the electronic, okay, electronic devices, so for example like our televisions, our fridge or so on, so make sure check is it follow the primary standard or not. That's good if you follow the international standard lah, very high accuracy, okay. All right, so for the electrical, so for electrical measurement, we also have the standard lah. Okay, we have also the standard. Okay, we have called the current standard, voltage standard, resistance standard, inductance standard, and capacitance standard lah. Okay, but I think for you, no need to know the detail on this one lah. Just the flow the surface on this one lah. But you know the electrical, we have the also we have the standard lah, the current standard, voltage standard, resistance, and so on. Okay, so this is the current standard lah. This is current standard. You can see this one. The electrical current is known as the flow of the charge carriers. Okay, therefore the current could be defined as the quantity of the electricity that pass a given point in the conductor during a time of 1 second lah. Okay, so this actually is the definition of the current, electrical current. Okay, so the coulomb is referred to the unit electrical charge. Okay, electrical charge we call the coulomb, okay, or quantity of electricity. Okay, it was the fundamental electrical unit from the all other unit were derived. Okay, 1 coulomb equals to 1.24 10 power of 18 electron. Okay, so this is we call the current standard lah. Okay. So I think we just don't need to explain detail here. So this is just fundamental. What is the current standard lah? Okay. So the current will be come from actually from this one. Coulomb divided by time. Okay. This means the ampere can be described as the coulomb per second lah. Okay. This is for the current standard. Okay. And then also we have the voltage standards. Okay, voltage standard defined as the potential difference between 2 points on the conductor carrying the constant current of the 1 ampere when the power distributed between this point is 1 watt. Okay, the volt is the unit of the electromotive force EMF and the potential difference. Okay, this is the voltage standard. For you, I think just this one is the derivation, the definition of the voltage. Yeah? The voltage is the potential difference. Okay, potential difference between 2 points of the conductor. That's we call the voltage lah. Okay, voltage. But for you, just only you know what is the voltage, what is the current, and then how to measure the voltage, how to measure the current. Okay. For example, to measure the voltage, okay, we can use the multimeter. Also, if you want to measure the current, you also can use the digital multimeter. For example, we have the okay. So for example, we have the electrical circuit here. Sorry, this I just use the drawing, but it's not clear. No. Okay, this for example, this is our supply, our voltage. Okay, for example, like 240 volt. 240 volt. Okay, this is our resistor. Okay, this is our resistor. Right. So to measure the voltage actually, so you have to you can tap your digital multimeter here. Okay, this is your positive. For example, this is your positive. Okay, so this is your negative. All right. Okay, so you can measure the voltage here. Okay, for example, using the digital multimeter, you can measure the voltage here. All right, if you want to measure the current, so actually, if you measure the voltage, you can parallel here. Okay, for example, you want to measure the voltage in the resistor, you can measure here. Tap here, and then another one tap here. For example, this is positive, this is negative. Okay, using the digital multimeter. Okay, but if you want to measure the current, not sure. Okay, measure the current, you have to something like this. Okay, okay, to measure the current, something like this. Okay, point here, then another point here. Okay, so this is 240. Okay, good. And then this is our resistor. All right, so this is our negative and negative and positive here. So will be in series. Okay, will be in series. We can measure the current here. Okay, we cannot measure the parallel. For measure the current, we cannot measure the using the parallel. Okay, so because if you use the parallel, so it will be short. So because this is will be, that's why you have to use the series. Okay, series connection to measure the current. Okay, that's the difference between the measure the current and measure the voltage. So the voltage you can tap here, automatically tap parallel Okay, for the positive and negative. Okay, but current cannot. So if you want to measure current here, so you have to tap here. So another one. Okay, maybe you can tap here. Okay, it's okay. Or tap here because the current will be same lah. Current here, current here will be. All right. So that's the to measure the voltage and measure the current lah. Okay. Next will be okay. This is for voltage standard lah. All right. So I will skip this one. Okay, and then we have the resistance standard. Okay, the unit of resistance is the ohm. Okay, you can see this one ohm. Actually, if you use the digital multimeter, this one also we can use to measure the resistance. Okay, directly using the measure the resistance here. Okay, so we have okay, we have you can see on the digital multimeter we have this one to measure the voltage. All right, so this one to measure the resistor, and also we can use to measure the frequency lah. Okay, and this one last one is to measure the current. Okay, to measure the current. This is on the digital lah. So I mentioned to you so for example, like our digital multimeter cannot use the resistor, you can use the indirect method lah. Indirect method, that means first you have to measure the voltage, and then second you measure the current. So you divide by voltage, divide by current, you got the resistor lah. So that's called the indirect. Okay, indirect measurement. Okay, so next is the inductance standards. Okay, so unit of the inductance is the Henry. Okay, Henry. So the inductance of the circuit is the 1 Henry when the EMF of 1 volt is induced by the current changing at the rate of the 1 ampere per second. Okay, that's the definition on the inductor lah. Okay, on inductor. Okay, this one also the inside the inductor lah. Inside inductor we have the magnetic flux, and then also we have the magnetic flux density. So this one no need to go through lah. Okay. Okay, so this is example. Okay, for the inductor. All right. Next is the capacitance standard. For you, you just know the unit for the resistor. Okay, what is the resistor? Is the ohms. The capacitance, okay, is the farad. Okay, farad, and then the unit of capacitor is farad. All right. So that is the for you. You just know the unit is okay. No need to know the detail lah. So you carry, for example, 1 farad equals to 1 coulomb per 1 volts. Okay, that is the definition on the capacitance. Okay, capacitance of the capacitor contain a charge of the 1 coulomb when the potential difference between its terminal is 1 volt. Okay, that's we call the capacitance. capacitor. Okay, so next will be on dimension 2 will be on the error lah. Okay, the error. So that I mentioned to you the any class. So when we measure for example, measure the battery. Okay, so from the standard dimension to you, the battery is 14.8 volts. Okay, 14.8 volt. Measure using the digital multimeter, maybe it got something 15 or 14 point something. So that we call the some error lah. So what type of error? So will be covered on the tomorrow class. Tomorrow class. Okay. Alright. So the type of error. Okay, we have the cross error, systematic error, and also we have the random error lah. Okay. So this is we will cover on the tomorrow class lah. All right. Okay. So any questions so far? So the list of standard will be passed after this, on the group lah, on the group WhatsApp. Okay. Any question?
Sir,
Yeah.
can I know, slide ni saya akan upload kat Yulen ke?
Yeah. No. I just pass to the group lah. Don't worry. After that I will pass to the group. On the WhatsApp group.
Alright, thank
Nanti
you.
saya akan masuk dalam WhatsApp group.
Okay.
Okay, class. Any question? Okay. All right. So at the end of this class, we should be able to know lah what is the measurements. Okay. What is the instrument device? Okay. The instrument. What is the definition of instruments? Okay. The terms. Okay. The standards. The units. Okay. You have to know lah on this in chapter 1. Chapter 1 on this morning lah. Okay. For the dimension to you is the instrument. Instrument. What is the instrument? That the device or the mechanism or the equipment that we use to measure the magnitude or the quantity. Okay. Or under the observation lah. Right. So you have to know lah. Okay. The instrumentation system and so on. Okay. Okay, class.
Okay, sir.
Alright. Tu semua dah lapar.
Okay.
Alright.
Yes, sir.
Okay.
Okay je.
Alright. Okay je. Alright. So I will stop here. So we continue on tomorrow. Okay. Tomorrow
sir.
on the.
Alright.
Okay, doktor.
Alright. Okay. See you tomorrow. Okay. Thank you very much. Okay. Assalamualaikum warahmatullahi
Alright,
wabarakatuh.
thank you, sir.
Waalaikumsalam.
Salam. Thank you.
Okay.
Alah.
Waalaikumsalam. Thank you, sir.